Hello everyone, welcome to a TouchDesigner tutorial where we'll be learning how to make a system that instances different geometry and packs it so that there's no intersection from a specific point of view of a camera. This is all based on this article written by Joe Hara, in which he describes this very specific technique for doing this in 2D, and I just adapted it and added some other things in order for it to work in 3D. The file for this project is available on my Patreon, and I also have an extra video showcasing how to change this network so it can be used with different shapes at once. So we can begin. I'm gonna delete everything. And let's start with a constant. So we can have a resolution, and also we're going to have the max count of instance geometry. Let's have it be 180, 1080 by 1080, and 500 for now. Next, we need to have our setup for generating all the different transforms for each instance. We're going to use noise stop for that. That is 1 pixel by 1 pixel, and make this 30-bit float RGB and turn off monochrome. Null, and this is going to be our position. And now we're gonna, for each frame, we're gonna generate a new transform that is gonna be checked for intersection with our previous transforms. So we're gonna do that by changing this seed with a frame. We use ABS time frame, and it's constantly moving. And this position, we need also another 2, one for rotation and one for scale. These are all the same right now, so I'm gonna change this one by just adding any number, like 100, and this one like 200. They're all different now. And this first one I want to be centered on 0. This one, the rotation will need to be between 0 and 360. And I add a math and multiply this by 360. And our scale, again, I'm going to use a math, and here this one actually should be, we can make it, I'm gonna make it mono for now, and here we're gonna rearrange this from 0 to 1 to like 0.02 and 0.1. Okay, now let's get our geometry that we want to instance. I'm going to use a box, and for now I'm going to use a null and select it here just so it's tidier. And here, if we add a transform, this is where we're going to use all of this information. But in order to do so, we need to get this from a top to a chop using the top to. Very important, this is set to immediate, and this is gonna be, let's actually copy these two lines, and this first one's gonna be dx, dy, dc. This one's gonna be rx, ry, rz, and sx, sy, sz. And let's merge and a null, and now we can use all of this for transform, translate, r, there we go. As you can see, if we play this now, it's moving around. We can now start the setup for how we're gonna keep track of all of this. We're gonna use another texture with a feedback to keep a buffer of all the previous transformations that have worked without having any intersections. So how do we do that? We're gonna select this tree, and get them into a layout. With top to bottom, scale resolution on, and it should be set here to nearest pixels, so it displays properly. And now it's connected to a feedback. And what we're gonna do is every time a condition is checked, in this case it's gonna be every time there's no intersection with our shape, then we are gonna add this to the right of this stack. And to do that, we're gonna use a crop, and then here on the crop right, set this to pixels, and the amount is gonna be these feedbacks width plus 1. Okay, and we can send it to 0, so just so we can see it. One column gets added, and now we can just use an over to put this over here, and the profile overlay should be to set native resolution and justified right. And right now it's blocking the previous thing that was there, and a quick fix for that is to set it to RGB-A, and now it's fixed, and we can set this back to RGB. There you go. Now we're gonna add a switch between these two, and just ignore this one for now. We're gonna add another switch between these two, and at the end a null, just so we can close this feedback. Let me add a keyword in so I can reset this. And drag the null to the feedback. And now this switch controls whether or not we add one of these columns to the buffer, as we can see. If I move this to 1, ooh, it starts adding all of them. Oh, we need to actually set all of them to nearest pixel. Now we can see whenever this is 1, more and more get added. Okay, now we need to actually calculate this value based off the geometry we generate. So let's render this using a geo. Very important here that you first click the output and drag it, press tab, and then add your geo. If you just add geometry out here, it's not connected, and you could actually come here and set it up inside of here, but I prefer it this way and not look at the camera. You can see it's moving around, and a render. That's gonna use the resolution we set, and this is gonna be tried to be mono and a constant material. And there you go. There's our geometry. Now we're gonna basically copy the same system, but instead of adding things to the right, we're gonna just keep adding the same information that we have on this texture. And this is actually the basis of the original article by Joe Hara. So we can just copy. Let's copy and paste the whole thing. And now if we replace each one of this like this, okay, now we're done the crop, and instead of this over, when I have an at, so like this, like this, like this. Let's reset this. And there we go. So this is basically the same. If this is 1, this gets added to the texture, and if it's not 1, it stays the same. Okay. Now we can actually use this to check for interceptions. This right here at any point will be kind of like all of our previous ones, and this is the current that we need to check against them. So we can use a comp to add them together. And this looks kind of ugly, so let me just select here instead. And now we can use a threshold, because this is being added. If any place on this image ever goes above 1, then there is going to be an intersection, because two different parts of the image are being added together. So then this threshold, we're going to set it to greater of less or equal and 1. And there it is. That's an intersection right there. You can now use an analyze to get the maximum. And this is going to be on. This is going to be 1 when there's an intersection, and 0 when there's none. Which is exactly what we need. So I'm gonna use a top 2 again, and this is gonna be called like intersection. Very important, this is set to immediate. And this is right here exactly what we need to control the switch. But if you notice, this when this is 1, we need to append a new slice, and so that means we want to append a slice when there's no intersection, though when this is 0. So we need to actually invert the signal. I'm gonna use a select here and rename this to append. And with a logic, we can invert and I don't know. And now we can control this using our append, and also this one. And if we reset and now play, you can see it's already working. Cool. Now we also need to be careful here because right now it's adding forever, always. It's always adding, and this is gonna get pretty huge. So that's why we have this max count parameter here. So we also need to check for that. Let's add a constant here. We're gonna call it count, and you're just gonna look at this feedback. It's width, and with an expression, we can copy this here, just to copy it. And now we need to check if this input value, so our count, is less than the max count, because we only want to add new information if we are still under that threshold. So input value less than the max count. And there we go. And now we can just add another logic, and we want both of these to be true. So we use combine chops and this is it. Now when this gets to our limit, it's gonna stop. So let me get this camera to be closer. Maybe I can make this slightly smaller, just so I can show you. Oh well, while it does that, we can use an image to mask a specific part that we don't want to be filled. So let me get the banana and just threshold. Well, first we need to fit this to our resolution. And switch it to off. And make this a little, oh, that's a little bigger. And now I switch this to 32-bit mono as well. I can just connect this to a save comp, just this one. And if I reset it, you can see now it works again. It's only It's only placing geometry that doesn't intersect with our image. Now there's an issue though. If I keep resetting this and something like this happens, where the very first attempt already was inside of our image, then every other one will always fail because that one is already there. So in order to fix that, we're going to use this second switch. And all we need to check is if we are on the very first attempt, so if this feedback is just the width of 1, then don't pass along the feedback, but pass along directly from the layout or from our information, in this case, the texture. So I'm gonna grab both of them, and we want just to check if the width of this feedback is 1. Well, we can actually use our count here and just count equals 1. And that's it. And now if I enable both of those, it works. And every single time that I reset, it keeps working. There you go. That's our main system. Now we need to get this information out from this texture so that we can do like cool animation and actually use this as 3D objects, because this is just a texture, right? So let's use a select from this feedback, and now we can crop and let's change this to pixels. And it's gonna be 0 and 1. This is gonna be 1 and 2. And this is gonna be 2 and 3. And let's make this all nearest pixels. And let me actually put this one on top and this one down here, so we are the same one as over here. So again, this is our position, this is our rotation, and this is our scale. And we can add nulls for each of those. We can call this anim position, anim rotation, and anim scale. Now we can instance. We're gonna select again our original shape and input into a geometry. Now, very important that this renderer here only looks at this geometry and it shouldn't be looking at any lines. Also, I can turn off this anti-aliasing. It's fine if you don't, but now I'm gonna need a camera for this. I'm gonna copy this one because the camera needs to be in the same position for the actual effect to show. Let's have another render which is gonna have our same resolution. Let me actually stop explaining this. And this render should also only look at this geo using this camera. And now for this one we can use whatever material we want. It's a font. And for that we need a light. And now we can instance here. Front state is going to be position, RGB, rotation, and scale. GMB. And there we go. There it is. And this is actual geometry, so we can do whatever we want with it. Right? We can add a point transform here and animate it using ABS time frame. Moving it around like that. We can have maybe here noise to the rotation. All this like that. And when it's 0, it's actually gonna show the actual shape. And also for color, you can add a noise that is gonna be 1 in height and count for the width. And changes to turn off monochrome. Let's have our null here, call this anim color. And use this in our instancing here. RGB. Now if I restart this and play it, you can see that because this is changing its resolution, the colors are jumping around. We can use our position as the second input. And that gets fixed. And it even gives you, if you lower the harmonics and raise the period, it gives you a nice effect. But you can do whatever you want with that. And I think that's it. That was all. Again, thank you very much to Joe Harvard this amazing article. Please go read it. And this whole file is available in my Patreon, and I will also have this extra video showing how to change this into a slightly more complex system, but you can use different geometry at the same time, not just boxes. Or even right now you can also play with this, you can, if you change this to I don't know, like a torus. Like that it works. If you make anything with this, please tag me. I would love to see it, and I think that's it. Thank you very much.